Welcome to our next unit called Data in Society. For our first assignment, we're going to learn about something called Ascii and binary representation. I'm going to start with our warm-up. Data in computers. Modern computers are electronic devices filled with lots of tiny wires. These wires carry electricity, and at any moment a wire can be on, which is high voltage, or off, which is low voltage. In fact, all the information you've ever used on a computer, like documents, videos, and pictures, eventually need to be translated down into these on and off signals. This is a really big challenge, and it's one we're going to be exploring for the next few lessons. Our overarching question of the day is, what system do computers use to represent letters and words? So think text. Think about text like on a Google Doc or text on Google Slides. How is the computer actually taking each of those letters and spaces and storing it on the computer? Ascii Text. In order to input, output, store, and process information, computers need to represent it first. Engineers used the tools they had at hand, which was wires carrying electricity. It's easy to tell if a wire does or doesn't have electricity flowing through it. So engineers needed a system based on just two states, electricity or no electricity, or in other words, on or off, which then ultimately becomes ones and zeros, which is binary. We have two key vocabularies for this lesson. The first one is binary system, and it's a way of representing information using only two options, on or off with the power, and then one or zero as you get further into the binary lessons. Ascii, A-S-C-I-I, is a popular system for representing text in binary. So this is how the computer actually does it. Ascii. There's lots of possible binary systems for representing the letters in binary information, but the most popular is called Ascii. Each character is represented with a different pattern of ons and offs. On the next slide, you can see the way patterns of ons and offs represent each letter in the table. And you're going to be using this Ascii table for your activity today. So here is the Ascii table. When it is a little orange circle, that means it's on. And when it's a black circle, that means it's off. So to represent a capital A, we would be on, off, 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 on. For a capital B, we're on, off, 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 on, off, etc. Now you'll notice that each of these patterns is unique because a computer can only take one pattern and turn it into one thing. Also be aware that this is just capital letters. There's different patterns for small letters because small letters and capital letters are completely different to the computer. And finally, the computer needs to know about spaces because spaces also take up space on the computer. So to represent a space between two words, they would use the off, on, off, 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 off pattern. So this is going to be what we're going to use in our challenges or in our different activities today. So you're going to be answering this question when you get to this slide. What can you represent using Ascii? And then we're going to move into the activity. So I'm going to talk through the slides now in the video, and then you will be doing it on your own after you're done watching the video. Ascii Challenges. In each of the challenges, the Ascii system has been used to represent a secret message. Luckily, you now know the Ascii system, so you're going to be able to decode the messages. Each challenge is representing the letters in a different way. So here's our first one. We have 1, 2, 3, 4, 5 different letters, and your task is to figure out which letter is on, off, on, off, off, on. And then you're going to write your response. So this is a 5-letter word, and each row represents one letter from this table. Here's a different word, same thing. 1, 2, 3, 4, 5 letters. Each row represents one letter. So you have to figure out which letter over here matches the pattern for each of these. So the first one again is on, off, on, off, off. Now it's your turn to make a word. So think of a word. Don't have it be too long, maybe like 4 or 5 letters. And then you're going to write the ASCII codes, the ons, offs on this slide. So for example, if I was going to spell the word dog, I would first do orange, black, 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 orange, black, black. So I would actually draw that right here. And then underneath it, I would do the O, which is on, off, on, on. And then I would do the G on the third row, which is the on, off, on. So you'll have at least 3 to 5 letters here that make up a word. And remember, each letter needs to have the 7 circles so we can translate it using the Ascii table. And now you actually have space to do that on this particular slide. Now the computer does not put blank areas between each character. So you need to now figure out what this says. So think about how many circles is each letter, and then you're going to have to count out up here see how many times you have that many number circles to figure out what these letters are, because the computer just smashes everything together. So in the previous slides, I separated the circles for you. This time I didn't, but still, one letter represents 7 circles. Now this is a slightly different one. This one we have these little animal faces. So this time the little bear equals on and the little cat equals off. So same thing, you've got to figure out what these rows equal as far as a word. And remember again, each letter is 7. So for example, in this particular puzzle, if you were going to find the letter A up there, it would be bear, cat, 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 bear. Now that's not the first letter, because we also always do start on the left and move from left to right as we're doing these when you decode. Then there's another question, are capital and small letters the same in ASCII code? I told you this previously in the video, so hopefully you were paying attention. Here is what real ASCII characters look like. So you can see that we first start with some really strange different things like null, but as we move down these columns, here you can see there's some punctuation. So there's the $sign, there's the %sign. We can even represent numbers using the ASCII system. And then here is the capital A. And again, it's on or off, on, off, on. So you'll see in here the binary, which is just the orange and black circles we were using before. And this is the ASCII for it here. And then we have capitals and we have small letters. And we also have, like I said, a bunch of other crazy things the computer needed. But don't worry about this one because you were using the simplified ASCII table for the previous activities. Now it's your independent work time. So you need to go through all of these Peer Deck slides. I have explained all of them to you, but you need to go through each one and answer all the questions. Then you're going to go back to Google Classroom and open up your copy of C1 Ascii Challenge. So there are 2 parts to this assignment. It is the Peer Deck slides first to learn about how ASCII works, and then you're going to go work on C1 Ascii Challenge, which is the second part of today's work. Once that's all done, then you can finish any other missing assignments you have for Creative Tech.